Okay. Hello, everyone. Welcome to second day of data science bootcamp. We will get started. In the first day, what we did, we loaded a JSON file and we cleaned it. And next, what we are going to do, we are going to implement few machine learning capabilities using just pure Python. That's exactly what we are going to do. Class, I'm audible, right? I'm audible. There's no issue
Yes.
hearing me, right? Okay, cool. Awesome. Cool. I'll quickly share my screen and we'll go through it. Okay. Open Jupyter Notebook on your system, guys. Okay, I'll start with sharing my screen. Is my screen visible?
Yes.
It is visible, right? So I'll quickly run it. So at least we have few things in plate. Okay, so this is the problem statement currently. This is people you may know. Does anybody have data.json open in their system? Let me check if I have it. Okay, this is data.json. Data.json. It's not an ideal way to do it. What I'm going to do, this is the JSON that we have. Now, what we are going to suggest, as you can see, there are 4 users. Okay. And they are friends with other users. So what we are going to do, we will utilize their mutual friends feature and will suggest them friends. Like you guys are familiar in Instagram, right? It suggests you people you may know and all that. So that is exactly what we are going to build. This is something not very easy, something you should use machine learning to do it, but we will use pure Python to implement this. Okay, let's come here. Everybody is aware with data.json. Do I have to share it again? Nishant, you don't have it. Okay, I'll share it. Share this with you. Not right now. Nishant, can you spell your email address? Nishant, you there?
Patel. Yes, yes.
Okay.
Nishant
Starts with
Patel.
Patel. Or
No,
Nishant
Nishant
Patel.
Patel.
Nishant Patel
2810.
2810@gmail.com.
Yeah.
Got it. Viewer or commenter, just in case. So this is a documentation that we have. I'll keep updating it. Okay, let's go here. If you scroll down, you will have the data.json. So this is the data that we were talking about. Here, Amit is friend with user 2, user 3. Priya is friend with user 1 and 2. Rahul is friend with user 1 and Sara is friend with user 2. So let's draw a graph. Okay. This may take time. Let's first understand the problem statement. What we'll do, we'll create 4 users. Cancel. Okay. This is user 1. This is user 2. This is user 3. And this is user 4. Are you understanding?
Yeah.
Okay. Cool. See, user 1 is friend with user 2 and user 3. So I'll draw a line here. User 1 is friend with user 1 and user 3. Okay. User 2 is friend with user 1 and user 4. Is user 1 and user 4. Just seeing it. See, 1 is friend with 2, 2 is friend with 1, and 2 is friend with 4. So there is a very high possibility 1 may know 4. You're getting it? Is everybody clear? Clear, right?
Yes.
Okay. Then you see user 1. Okay, we did user 1. User 3 is friend of user 1. 1 is friend, so we have a single line. And then user 4 is friend with user 2. So yeah, we have it. So in people you may know, user 1 may know user 4 because there is a mutual of 2. Got it? This is exactly what we are going to implement using code. Any doubt in the problem statement?
No.
No, right? Okay. Now that our data is clean and structured, okay, build people in social network, the user connect by suggesting friend zone, analyze mutual friend, recommend potential. Okay, let's understand the logic. Okay. If user A and user B are not friends but have mutual friends, in our case, if you check here, 2 is mutual friend of both 1 and 4. Got it? So 1 may know 4. In let's take an example. I mean, see, I mean, if I know a lot of people, let's say there are more mutuals, there are very high chances that I may know that guy. There's no doubt in the problem statement, right? Devesh, Nishant, Krish.
Yeah.
Yes.
Yeah.
Okay. Okay, I already give an example. See, Amit is friends with Priya and Rahul. Priya is friend with Sarah. Amit is not directly friend with Sarah, but Priya is a mutual. So so suggest Sarah to Amit as people you may know. Okay, so let's try with code along. Okay, please open your notebook. What we are going to do? What we did in the first class, we will try to load the data.json. Do you have the data.json or shall I share it with you again? Krish and Devesh, you must have it. Nishant, copy it from here and save it as data.json.
We should create a new file, right? For this.
Yeah, create a new file definitely in a folder. Keep it structured so that when you go back, you can easily go through it. What I'll do, I'll open a notebook. Okay. Coding along for you guys. We will load the data. The first argument is file name. That's exactly what we did on Sunday. Then we open a file. The file name will be the parameter in read operation. As a Nishan, pay attention if you are not able to understand. Then I'm loading the file and I'm directly returning json.load as f. Any doubt in this, Nishan, the code that I just wrote?
No.
All right, I'm reading a file, that's it. Okay, I may not have data.json. Let me check. Data is equal to data. Yes, let me know when you guys are done. Just reading the file. We have to read the file. Once you're able to see it in the console screen, we are good. Is it done yet? It's done, Krish, right? Devesh, Nishant. Come on, we did it on Sunday. Done, right? Oh, okay. Let me know when it is done. Okay, so next logic, what we are going to implement is find people you may know. So this is the logic we are going to implement. Okay, so what we are going to do, we will first see, this is the implementation, this is the function call. And here, let's understand what is the logic. First, we are loading the data. Then we are seeing user number 10, user ID 10. Then this is the recommendation. So find people you may know. So the input is 10 and 10 may know user 11, 6, 7, 14, 18. Okay. These are the people 10 may know. Just give me a minute. I'll show you what exactly I mean. JSON viewer. Okay, this is the long user. Let's not format it. This is the long user that we have. What we want to see, that who we can suggest user 10. So there are 5, 8, 9, 16. These are the mutual friends. Then we will go to their friends and then we will check like which are the mutual friends and whom we can suggest. Got it? This is the data that we need to share. What I'll do, I'll share it, keep it here. Like instead of data.json, try loading this. Got it? Please replace your data.json with this new file and let's call it massive data.json because it has more files. Okay, let me know once done. You're following, right? Is it done? Let me know when it is done. Done, right? Okay. Okay, so let's understand the logic. What we are going to do. Okay, first we are creating a user friend dictionary. Then we are iterating through user in data of users. Okay, so people you may know will take two arguments, that is user ID and the data. Data is our JSON and user ID for whom we want to find users. If you iterate through this, so this will be the array it will iterate through. Okay, and the first logic is in the dictionary user of ID. That is, if you come here, that would be 1. User of ID 1, get the set of user friends. So the reason for doing this is to get all the unique friends that we have. Okay, 2, 3, 4, 5, 6. It is a level of sanitization and it is also required. Then we have a set. Okay, so this will create a dictionary of, let's say, 1 with 2, 3, 4, 5, 6. 2 key value 3, 1, 3, 5, 6, 7. 3 key value 1, 4, 7, 8. Got it? Can you all visualize it?
Yeah.
Okay. Then if let's say user ID not none in user friends is required when let's say there is a user ID which does not exist, then it will return an empty array that we can't recommend friend. There are, let's assume there are 1 to 10 user ID and somebody has entered 11. So this will return an empty dictionary so the program does not fail. Okay. Then we want to check the direct friends. Okay. So if a user friend of user 10, let's say if you come here, come to user number 10, the direct friends are 5, 8, 9, 12, 16. These are all the friends of user 10. Got it? Then we again create a dictionary called suggestions. Okay. Are you following? Shall we code till here and then go ahead? I think that would be better, right? Yeah, let's code till here. Okay, first step is we want to create a dictionary which looks something like this. Let's say 1, then it will be set of whatever the friends of 1. Got it? Got it, right? Let me know when done. Let me know when done. Should be done by now. It's done, right? Okay, you are getting an output similar to this, like if you return it or if you print it, this is how it should look like. Devesh, you good? Is there an issue? Let me know. I'll solve it.
Sir, can you show the code again?
Or share your screen. We'll do it together. Now tell me, what are we trying to solve and where you are not able to solve it?
We are finding the mutual friend. Like, what is the
No,
connection?
currently, what exactly we are doing? Like, why the set of line of code that you wrote? Explain me. Like, what is the purpose?
The function we have called user friend is dictionary, in which we iterate the data, and where we are creating the new dictionary friend user friend, where a user ID equal to we are setting the friend, matlab ki, like we can unique values.
Not I mean, yeah, unique we want, but see what we are doing. We have created dictionary where IDs are directly mapped to an array of their friends, and we are using set to sanitize it. Let's say there are duplicate values because of the data science scientist. It is our duty to sanitize the data at every step we can. Okay, so that's exactly what we're doing, and I can see it's a spelling mistake. User friend, you know, you did friend. No, the above one was correct. The below one was causing problem. Okay, print user friend. Print or return it, like, I mean, yeah, print it. That would be better. No, you can't print it outside the function. You have to print it inside the function, and then you have to call the function. Okay. Nishant, are you good? Are you done?
Done.
Cool, right? You're able to get a dictionary that is similar to what was on my screen. Correct? This should work for you. Okay, run it and call the function. If that does not work, let me know. Okay. Use tab to finish. Devesh, you can use tab. No, while you're typing, if you use tab, it will auto-complete. No. You have to first type FIND and then you press tab. Yeah, see? Yeah, call it. Okay, give it user ID 10 and data. And run it. See, this is everybody getting similar to this? No, what is this? 1, 2, scroll down. What is the problem there? 1 of 2. No, why is it iterating so many times? Is a friend of user ID is equal to set user friends. Yeah, what is the problem? No, you are iterating through data of users, user friend, user ID, set, and user friends. Okay, there is some problem. Is there any problem, Krish? Can you figure out on the output? They will scroll up.
That's right.
Is one, then okay, it's repeating.
His
See
print,
one.
his printed line is
See?
in the array.
Yes, the print statement is
Outside of
inside
the
the
for
for
loop.
loop. It has to be outside the for loop.
Yes.
Okay, got it.
Okay.
Cool, right? Now run it. Run the find people you may know. Okay.
Yeah.
See, now it is correct. So anyways, the logic was correct. The print statement was inside the for loop, and we are good. Okay, back to my screen. Devesh, please stop sharing. Okay. Then we come to direct friends. So what we want to achieve, who are the direct friends of user 10? Currently, our input is 10 and user 5, 8, 9, 12, 16 are direct friends. Got it? Okay, please implement that. Before that, let's also add a sanitization. Okay, you are understanding why this is needed. Okay, Nishant, if you can explain why this is needed.
If like there is no user ID, like user enter ID like 11 or 10, but it doesn't exist in our data, then it will show error.
Excellent. So we are not showing error, we are returning an empty array.
Yes.
Okay, so that our program does not stop. Okay, please implement this line, then we'll move to direct friends. Guys, let me know done. Should be done by now.
Yeah, that's it.
Done, right? Nishant, Devesh. Yeah. Okay. Did you guys implement direct friends?
Yeah.
Yeah. Okay. Then we come to suggestion. So what we will do now, we will create a dictionary for suggestion. Okay. This is an empty dictionary. We will iterate to friends in direct friends. Okay. So how it is working? Let's see. There's a user 10. Okay. And these are the direct friends. Like they are already friends with them. User 10 is friends with 5. User 10 is friends with 8, 9, 12, 16. Got it? Then what we are going to do? We will again iterate to friends of user friends. So that means we will iterate through, there is a 10, we'll go to 5, and we'll get all the this thing, all the friends. We'll iterate through it. So see, 10 is friends with 5, and 5 is friends with 1, 2, 6, 10, 11. So 10 may know 1, 2, 6, 10, 11, right? Okay. Now, as you can see, 10 is already present. So 10, I mean, suggesting your own profile to yourself is not something you should do, right? So there is an if condition. There is an if condition. If mutual is not equal to user. So let's say 10 should not be suggested to themselves. So this is there. And mutual not into direct friends. Here, if you see 10, okay, 10 is friend with 5, 8, 9, 12, 16. These people should not be suggested again. They're already friends, right? Okay, so hence we have another condition. If mutual, not in direct friends of 10, then this happens. So what we are doing, we are creating a suggestion dictionary where, let's say here, when we come to 5, there is 1. 1 is not friend with 10. Are you able to visualize? Shall I draw it? Good, right? You guys are able to visualize what I'm trying to say. Okay. Okay, we go to 10, we go to 5, you see 1. What will do? It will create a dictionary of 1. It will be 1. And then if 1 is present in a dictionary, it will increment. It will be incremented to 1. And if it is not present, it will be set to 0. Got it? Got it? Any idea? Any confusion in this? I think this part is something very specific to Python. Do you want me to go deep down this specific code?
What does the get method do?
Okay, I'll show you what we'll do. Let's create a dictionary. T is equal to, this is for reference, it has nothing to do with the code that we are going to build. Okay, so T has 5. Where did it go? Okay, yeah, T has 5. Okay, T dot get, I think we have to create a dictionary like this. T is equal to A 5 B 6. Get it? You do a T of 5. T dot get A, then you'll get, oh, T dot, sorry, it's a variable, my bad. T dot, okay, somebody who is used to VS Code. Okay, T dot get, you do a get, it is 5. It is similar to typing T of A.
Of A. For value, getting value. Right.
To getting the value. The reason why we are using get is that when it is not present, you will get none value. T dot get, let's say C. C is not present, you will get none, nothing. So it will not run into an error. And it will take a second argument. Let's say if it is not present, return 0. So it will return 0. Get it? First argument, it finds it. And if it does not find it, this will be set to default value. So what we are doing currently, the suggestion dictionary is empty. Okay. When the friend occurs for the first time, it will be set to 0. I mean, it will be set to 1. It will be set to 0, then plus 1. Got it? If it occurs again in somebody else friend list, it will increment it to 2. Are you getting it? So we have score. So here in this case, 11 will have the highest score and 22 will have the lowest score. So we, with our algorithm, we can say that 11 is the very most probable that they may know them and they'll connect with them. Get it? Any confusion in this logic? Any confusion till now?
Sure.
No, right? Okay, let's implement this. Okay, remember, we have direct friends. We're iterating through the direct friends of 10. We're iterating through the direct friends of 10, which is 5, 8, 9, 12, 16. We are going through all the friends, and if in the friends, if the user themselves is not present, the user should not be recommended to themselves. And if they are already friends, then they should not be recommended. Got it? This is the logic. And if that happens, we get the value, either set it to 1 or increment it to 1. Any confusion, anything? No, right? Cool. Okay, please implement till now, then we will go ahead. Any confusion, let me know. I am here to help you guys.
Done.
Done, right? Nishant, Devesh, both of you?
Yes, sir.
Nice. Okay. Okay. Can anybody share their screen? Who want to go ahead and share the screen? Trish, are you sharing your screen?
Yeah.
Okay. Now with the notebook. So what we are getting is, okay, suggestion friends in if mutual fund, sorry, mutual friends and not user, mutual not in direct friends. What we are getting, this. One is one. Now tell me, everybody pay attention here. You guys are done, right? All of you are getting similar output. Okay. See,
Yes.
1. The score of 1 is 1. Score of 2 is 1. Score of 6 is 2. Get it? Score of 11 is 3. 3 is 1, 4 is 2, 7 is 2. Okay. Now tell me, out of these friends, which is the maximum possibility that he will send a request to that friend? That he definitely knows it. Like which, out of all the friends, which friends has the highest possibility?
11.
Why so?
Because it has occurred the most number of time.
Exactly. Excellent. So that is the score that we have given. So it would be more understandable if we sort it in a way and we show it, let's say 11 and whatever the next number comes, and this is how we sort it. So come to my screen. Please stop sharing, Krish. Thank you for your presentation. I'll share my entire screen. Just a second. Yep. Okay. So now we have this thing. So we have that array. Now this is the Python function. Is anybody familiar with? Oh, I'm not sharing my screen yet.
No, no.
Oh, my bad.
Yeah.
Can you see my screen?
Yes, yes.
Then we have this sorted suggestion items. Anybody familiar with what exactly this function does?
Sorted.
It's a Python function.
Inbuilt
It
function,
sorts
right?
lambda, reverse.
I've used it, but not able to recall.
Okay. I'll explain. So sorted is a function. If you pass an array to it, it will sort it. It will sort it in ascending order. Okay. But in our case, we have a dictionary. Okay. So what we are doing, we are using an item, which is also a Python function, which converts a dictionary into a tuple. You see here we have a dictionary A5. If I do dot items, it will become a tuple. Okay. The first argument is the key. The second, first value is key. The second value is value. Get it? Key and value. Okay. Everybody pay attention here. Then what we are doing, we are asking them to sort this tuple. We are using a key. Key lambda is something which is very Python specific again. Lambda is, you call it an inline function. So you write it in a single line and you can call it, and I mean you can sort of like it is a callback function which is used here. So on what key we should be sorting? So what we are telling, take x as the argument, which is the value of this, and take the second element. The position is first. That means take the second element. So in our case, this is the dictionary. Take the second element and then sort it. Okay. So if we put sorted, then A and B will come first because it is an ascending order. But in our case, what we want, the key with maximum value should be at the top. So what we are doing reverse equal to true.
True.
So that it is from descending to ascending, not from ascending to descending. Got it?
Yeah.
Got it, right? Okay, let's implement this and print the sorted suggestions or return it. Let's see what the output is. Let me know when done.
A sorted suggestion is returning a list with tuples.
A list of tuples, right? Okay. Okay, go ahead. Just return the user ID.
Only user ID.
Only user ID. Use list comprehension so that you have practice of it.
Okay. So, for so,
So the tuple that you are returning, that is 11 as 3 value, right?
yeah,
And 11 is at the top,
yes.
correct? So yeah, we have verified that. Guys, quick. Should be done by now. It's a single line of code. Nishan, Devesh. Done, right, Devesh? Yeah, let me know when you're done. Okay. Cool. Yeah, go ahead and just return user ID. Okay, use list comprehension. So that's the only thing that we value. I mean, we need. We don't want to show user that this is the count, and that's why we are suggesting you. Nishant, any blocker? Okay.
No, no.
Nishant, are you doing the list comprehension part or are you still stuck at sorted?
Sorted.
Okay, share your screen. Let's finish it. We don't have a lot of time. Okay, what is the problem? Okay, sorted suggestion of item. No, you're using it. It's an indentation error. You're supposed to use it with a tab. You're writing it outside the function. Yeah, similarly, sorted suggestion. And why write like this? See, sorted is a function. The first argument is an array or a tuple. The second argument is was the lambda function. And no, suggestions.items will go suggestions.items, and also like put it inside the function. It is outside the function. No, lambda. So what we want to do sorting on the second element, right? And first of all, put it inside the function. It will not run sorted suggestions. You're seeing it's outside the function. Yeah, now it is okay. Then in the second argument, you want to do it on the second part. So lambda space x colon x of 1. And don't use capital is reserved for constants. No, colon x of 1. It's x of 1. It's dot 2 does not make any sense. And is lambda. And see, that's you're calling x. This is how you use a function. Put a lambda. Lambda. बकरी नो ब लंबा नहीं लैम्बडा हाँ x of 1. See, 1 is a function. You put it in a square bracket. And true has to be capital true. And now it should work. So understanding, did you understand the whole function?
Yes, sir.
Right. And why did you put return user ID? It's something we did not even go there.
I'm working on it.
Okay, now print the sorted suggestion. At least you have an idea that's working or not. Oh, there's some indentation error somewhere. We try to fix it. Print suggestions. The top part. I mean, you see print suggestions somewhere. Yeah, there. Just cancel the tab and put it again and check. Put it outside. It should be out of the both the folder. There's this extra space. Can you see it? Yeah. Do a backspace. Press tab. No. This won't work. See, the indentation is key in Python. The reason Python was implemented because people were writing bad code, and indentation was something they want to sort of globalize. Key. This is how you write a function. Don't write in a single line. Space and indentation is very key in Python. Or else you use braces in C, C++, and Java. Okay, right? Now run it. You should be able to get sorted suggestions. So see, the function has to be called outside the function. Find people you know, you call it outside the function. Run it. Devesh, Krish, we are good, right? Are you guys able to run the list comprehension?
No, I need a little help in that.
Definitely. Okay. See, items S. Yeah, run it. Now what is the error? Sorted expected 1 argument got to what? What's the problem there? Anybody? Can you guys fix it?
We have to give key equal to lambda.
See, great. Okay. Give key equal to lambda. That's a keyword argument.
Assign lambda. Before lambda, you have to
Before
put
lambda, use key equal to lambda x of 1.
key equal to. Yes.
Yeah, now run it. And see, these are something you should know, that I am able to use sorted function. You don't have to memorize, like this is how it should be. Do a simple Google search, you'll get all the what do I say, syntax and everything. There are other arguments as well, which we can use it. Now you're understanding, right? 11 of 3, 6 of 2, 4 of 2, 7 of 2, 14. So there is a very high probability that 10 may know 11, considering his direct friends and mutual friends. Get it?
Yes.
Okay. Okay, Devesh, are you done with the list comprehension as well?
No, sir.
Okay, Chris, share your screen. We'll do it on your screen.
Is it visible?
Yeah, visible.
Yeah. You see.
What is the help that you need? It's too small. Just give me a minute. Pull it to my monitor. Are you using a monitor by any chance?
Me?
Yeah.
No. Laptop only.
Okay. Okay. Go to the screen. Show me what is the problem.
Yesterday or day before yesterday, we used list comprehension, right?
Yes. On Sunday we did. So
Sunday
that is
we did.
user ID.
Yeah, so a user ID will be something we will be returning. And
Correct.
yeah, so what exactly is this statement or like this?
Just 1 minute. I mean, I'm doing your screen. Am I able to see it?
Should I do it bigger? Like,
Yeah. Increase the font. That will help.
is visible or still not?
It is visible. Okay, then we have. Okay. It is user ID for user ID in sorted suggestions. Okay. Hey, suggestion is dictionary. We are supposed to iterate through sorted suggestions.
So here,
It should work then after that.
okay. Still, like these two are actually parameters kind of thing, right?
Yes, your sorted suggestions is a tuple. I mean, it's a list of tuples, right?
Okay, this
So
is
the
a
first
list of
argument
tuples.
and second argument. Yeah. As
And
you
we
can
have
see it, the
two
first
things.
argument will be the yes.
So we have to return this user ID.
We want user ID to be returned, and that's exactly what you're doing.
And if I return mutual,
it will return count.
And value, okay, got it.
Got it, right? If you want to iterate a dictionary, it has to be dot items. Got it?
Okay, got it.
When you use dot items function, a dictionary gets converted into array of tuples.
Tuples, right.
Okay, we are good. Devesh, are you following? Nishant? You
Yes,
guys are
sir,
able
done.
to do this? Okay. Now, I'll again share my screen. We are able to solve a problem. I mean, in my opinion, we are taking a bit longer. I think I plan to start NumPy from today. I don't think that is possible now. We'll do something to increase our speed. Okay. Can you see my screen? Okay, I'll write it down here. See, what we did is very basic. Let's say if we want to really find mutual friends, now tell me what are the factors that can be taken into consideration. I think direct is okay. Friends of friends is something we can take into consideration. What else? Pages they like, right? Let's say if I'm liking few meme pages, 3 meme pages, and Nishant is also liking those 3 meme pages, then there is a possibility we can be friends, right? Give
Yes.
me an affirmation. That means we can be friends, right? There's so many such factors. Let's say I and Devesh are of same age. Let's take an example. Same age can also be a factor. Okay. Then let's say we have same interest. I mean, same interest that you come to page of, I mean, page that you have liked. Okay,
Yeah.
so many factors. So when you are developing an algorithm, your first goal is to determine like which factor you will give more weightage. In our case, we are giving more weightage to friends of friends. Then we are giving more weightage to, I mean, the algorithm is not done yet. We are giving it to the pages they like. Then let's say what is their age difference. Let's say we studied in same university. Okay, same university. Okay, could be same city. Same city. Instagram has so many details of our us of us. Let's say we all visited. I mean, we frequently go to Mess. I mean, Mehsana is a place in Gujarat, Devesh. We frequently go to Mehsana. I mean, it's like 5 times. Let's say whenever there is festival, we go there. See, I mean, I mean, preference city. Okay. Anything you guys can come up with? Anything else? Devesh, Nishant, Krish. Anything to find mutual friends?
Same
I
thought.
mean, people they may know. Sorry, my bad.
Same thought.
Same what?
Thought.
How do we get the thoughts from our algorithm? We have this data, right, where they are going geolocation and all that.
Hmm.
How do you get thoughts?
Working at the same place.
Same colleagues.
Yeah, colleagues.
That's there. So
Same
many parameters. Yes, same what?
same groups. They are in like
Yeah,
connected
same
with the
group.
same.
Yeah,
Similar
following same
interest.
ID models also can be a parameter. Like you know, influencers following same influencers. Okay, that also can be a parameter. So many, so many. This is endless. The reason why I'm telling you that no algorithm is perfect. Okay,
Hmm.
we have no idea. So we will come up with an assumption. It's not like you have built something and it is definitely going to work. There may be a so how do you decide if your algorithm is working? You decide on the basis of click, like the output. The friends that you're suggesting, are they really making them their friends? Where did the screen go? Yeah, are they really making those friends? So this is only when you decide. There is very high chance to write an algorithm, and without putting into practical use, we can't determine it will work or not. We are just going with assumption. Currently, let's say we did not take case of colleagues or group. Group is something that we massively miss. Let's say there is a group and we are already part of that group. We are very active in that group, and that's something we did not take into consideration. So our algorithm will not work. Okay, I mean it will not work, but to an extent. So this can be like you're following a same group, you have same thought process. So in the group that you can go through it. So in data science, the implementation is your result. Like there is no other way if it is working or not. Okay, no matter whatever algorithm you come up with, it is mostly trial and error. Initially, you felt like maybe friends of friends is something that is a bigger factor, but then you later change the count. Then you give priority the pages they like. Got it? Okay, let's go to the next problem. What we did, okay, we did friends they may know. Now we will do pages they may like. Similar problem. I'll try to finish it early. Okay, give me a minute. I'll open. Then we have pages they may like. Okay, it is a very similar problem. So currently, let's say user. Okay, we already have the massive.json. Okay, user 1 has liked pages 101, 102. User 2 have liked pages 101, 102, 103. So user 1 is friends with user 2. So user 2 also may like page 101. Get it? Same problem, same implementation. Let's try to finish it quickly. Okay, so we have practice on that. Okay, go ahead and load the file, create a new file. I think let's create a new file. Okay, and this time name it pages you might like, and load the data, load the massive data.json, and let me know when done. Okay, finish it quickly.
Done.
Done, right? Okay, cool. Now write a function which is find pages you might like. Okay, same function you have to write. First argument will be user ID, the second argument will be data. Try implementing it. I think it has the same logic. If if they are already liking that page, then they should not like it, right? Those are the logic. Okay. Are we good? Let me know when done, guys. Do you need help? Just mind you, it's not exactly the same. There are certain tweaks we are going to do in this recommendation algorithm.
Okay, up to the null I have done. Like
Up to what?
if we have no ID, then we return like empty list.
Okay, so currently what you have is that you have user ID and their like pages. Till that you have done, right?
Hmm.
Okay. Okay. Nishant, are you there?
I'm working on suggestion part.
Sorry, what? You're working on what?
I'm working on suggestion part, like mutual.
Oh, nice. Okay, okay, okay. Okay, cool. Let's not go there. I'll quickly wrap this up. Okay, I'll explain the logic. This is find pages you might like. Get it?
Okay.
Same logic, user pages. Same you populate. You get
Yes.
set of user. Okay.
Like
So it will again create this thing. One will have 102, two will have 102. These are the like pages that we have. Okay. If it is empty, if the user ID does not exist, returns an empty array. Okay. Now currently we are targeting. Our target is user one. Okay. User one's like pages. Then we have all the pages they have liked, which is in our cases 101 and 102. Are you able to visualize what I'm saying?
Yes.
No problem in that. Okay. Then we are using page suggestion as a dictionary. This is an empty dictionary. We'll populate with the scores. Okay. We are iterating through user pages.items. Okay. User pages.item is all the users, the dictionary that we just created. It will have user one liking an array of 102, 103, user two liking an array of this. Iterating through it. And when it is an item, the first argument will be the key, second argument will be the value. Got it?
Yes.
Now, this is an important part. If other user not equal to user ID, what we are doing, this is other user. I mean, it's not the same people, right? What we are doing, this, understand this. Shared pages is user like pages dot intersection of pages. You're getting it, what we are doing? Any idea what we are doing?
No.
Set theory, you guys are familiar with set theory. You can't pass your standard without it. Okay, then let's go ahead with the logic. For page in pages, here in the pages, if page not in user like page, if user had already not liked the page, same logic. Page suggestion of page You go a page suggestion, get the page, and this time with 0, do a plus of length of shared pages. Shared pages is coming from here. Okay, what exactly we are doing here, if you see, in this dictionary, user 1 has liked 102, 103. User 1 is friend with user 2. User 2 has like 102 and 103. If we do an intersection of both these array, we can't do intersection on array, we have to convert them into set and then we have to do it. If we do an intersection of these two, what will be the value?
102.
102, right? Okay. So there is a chance they have this much similarity. So user 1 may like 103. But if we go ahead and find, let's say 101 and 102, which user has more of that? Let's assume I can't find the user currently. Let's assume there is user 4. It is already liking 101, 102, and it is liking some other page. So there is a high probability that it will choose user 4 over user 2. Okay, because in user 2 only one page matched, whereas for user 4 two pages matched. So then their preferences match more. That is the exact logic that we are using. This is the shared page. Okay, setting it to 0 if it does not exist, it is already there. Then we are adding the length of shared pages. Previously we were countering it 1, but right now we are giving weightage to whatever is the shared pages. The count of shared pages. Let's say there is a common of they are sharing. I mean, there are 3 pages that they both like. So then the other user suggestions like page should have more weightage, right? Get it? Any question in that? No, right? Yeah. Similarly, when you are sorted, you reverse sort and return the page ID and score, and then you see 103 is something they like the most. They may like the most, considering 102 has 3 has the highest score. And let's check. User 1 is friend with 2, 3, 4. We go to 2, 103 is there. 3, 103 is there. Okay, user 4. Okay, not there. And see, there is 101, 101, 102. This will also is making it. We are doing intersection and we are summing it. Clear on the logic? No confusion, right? Okay. We are short of time. What we'll do, maybe use my screen and try to replicate it. I mean, you guys have understood the logic. Just go through the screen and replicate it on your system. Any idea, anything? Sorry, any questions, my bad. Any questions? Any doubt? Devesh, you may not be familiar. Maybe you can watch the video later. Guys, let me know when it is done.
Yeah, sure.
Is it done, Krish?
Yeah.
Yes.
Devish, you currently go through the code and I'll share the video. We'll go through the part where you missed. You should be able to follow that. Nishant, any problem?
No.
All right. Guys, quick, I have a call at 10:30.
Yeah, done already.
Done.
You're done, Nishant. Devish, are you done? No? Okay, cool. Okay, so both Nishant and Krish, you guys are able to understand what the logic is, right?
Yes.
Not an issue. The code is running and it's perfectly fine. Okay. Devish, I'll share the snippet with you. Maybe you copy it yourself and understand it. I'm extremely sorry. I have to drop. I have to get my breakfast and there's a call at 10:30. So that's why I would be leaving. I'm sharing the document. Can you hear me?
I guess he
Did
might
we
be
there?
having internet issue, I think.
Yeah, I think we lost him. I'll text him on WhatsApp.
Okay, sure.
Okay, cool. Let's sum it up the day 2 here. And what we are going to do. So I'll be on on holiday on Sunday. That's why we are doing this class on weekday. So we will next meet on 31st of May. Yeah, cool. In the meantime, I would suggest understand Python thoroughly. Okay, understand NumPys and Pandas. That is something we are going to touch upon next week. We will be starting with NumPys, and then next week we'll take on Pandas. So whatever we did with pure Python function. We'll be start using library. These are extremely fast library. You can do terabytes of data analyzing, indexing, sorting, everything using this thing. You can't do that using pure Python. Okay, that's something we are going to do next. Okay, thank you everyone. Thank you so much for the time, and see you next week. Yeah, okay, bye, tata.